Hey guys, welcome back. So let's go ahead and look at the objective for today. Today's objective is I can solve a system of equations by graphing. Now before we actually solve a system by graphing, we need to know what a system is. A system of equations is a collection of two or more equations with the same unknowns, and the unknowns being the variables. Now the solution to a system is any point that lies on each of the lines of the system, right? Also, you can say that it's true to both equations. Now, what do I mean by that? So let's take a look at this little diagram I drew. Now, A would only be a solution to 1 because it only lies on 1. B would only be a solution to 2 because it only lies on 2. Now, C is the only one that is on both lines, so that one is the solution to the system. Now for number 1, what we're going to have to do is identify if it is true to both equations, because if it's true to both equations, that means when you graph it, it will be the point of intersection where it lies on both of them. So let's go ahead and start out by plugging in the point 8, negative 9 into the equation x minus y equals 17. So let's go ahead and do that. So you're going to put for x minus y equals 17, parentheses 8 minus negative 9 parentheses equals 17. So all we need to do is plug that into our calculator over here. We'll put parentheses 8 parentheses minus parentheses negative 9 parentheses. That is going to get us 17. So then we get our 17 equals 17. This is true. So now you got to plug it into the next one. Go ahead and do that for me. All right, now when we plug it into here, we're going to have 8 plus negative 9 equals negative 1. 8 plus negative 9, if we plug it into our calculator, 8 plus negative 9, that is going to get us a negative 1. So, negative 1 equals negative 1. This is also true. Now right here, where it says the point is true to both lines, since we have true in both sets of the equations, we can go ahead and say that yes, it is a solution to the system. So let's plug in 5, 2 to number 2. The first equation is 2x minus y equals 8. Go ahead and plug 5, 2 into that equation. All right, so when we plug it in, we get 2 times 5 minus 2 equals 8. You wind up with 10 minus 2 equals 8, which is 8 equals 8. This is true. Now let's plug it into the other one. So we have 3x plus 2y equals 20. Go ahead and plug it into this one. Tell me if it's true or false. Alright, so when we plug it in, we have 3 times 5 plus 2 times 2. That's 15 plus 4 equals 20. That's going to get me 19 equals 20. This is false. Now again, you need to have two truths for it to be a solution. Over here we have a true and we have a false. Therefore, this one is not a solution to the system, meaning it is not at the intersection point of the two lines. So let's go to the next slide now. Now the steps to graphing are the following. First, you need to graph both lines of the system. Then you want to locate the intersection point xy. Finally, you want to check the solution into both equations. Okay? If you need to press pause, go ahead. Otherwise, I'm going to the next slide. So let's go ahead and solve our first system of equations by using the graphing method. We're going to start out by graphing the first equation, which is 2x minus y equals 4. Now, what would be the best method to use to graph this equation? Alright, so let's go ahead and use the thumb method. Now, when you are using the thumb method, you're looking for the x and the y-intercept. To find the x-intercept, we have to make y 0. And to make y 0, again, all you really need to do is use your thumb to cover up the y. So you wind up getting 2x equals 4. So what is the x-intercept then? Alright, so for the x-intercept, we get 2 because 4 divided by 2 is 2. Alright, now to find the y-intercept, it's the opposite of the x-intercept, obviously. So we have to now make the x 0. So by making x 0, you cover it up with your thumb. Be careful not to cover up the negative because the negative is part of the y. So now you have negative y equals 4. So what is the y-intercept now? Alright, the y-intercept is 0, negative 4. So now we can go ahead and plot these 2 points. You're going to plot the point 2, 0, which is right here. Then we're going to plot the point 0, -4, which is right here. Now we can go ahead and connect them with a ruler. There is my line. Now let's go ahead and graph this one. The next one is y equals -x plus 5. What would the best method for this one be? Alright, we're going to now use slope-intercept form. First we have to identify the slope, and the slope is always in front of x because we know that we have the equation y equals mx plus b. The number that's in front of the x is -1. So -1 is my m, or you can say -1 over 1. And then the y-intercept is going to be 0, 5 because that is the number that is after the x. Okay, so the way you do this is you start out by plotting the point 0, 5, and this slope is -1 over 1, which tells you to go down 1 and then to the right 1. So doing that, you're going to go down 1 to the right, down 1 to the right, and you're going to keep going until you can't go anymore. So there's my points that I'm plotting, going down 1 to the right. And you can already kind of see where the intersection point is. So connect the dots, this is what it looks like. So what is the solution to this system? Alright, the solution to this system is 3, 2. Now step 3 asks you to check your solution. It's really easy to do that because all you need to do is plug in 3, 2 into those equations. So we're going to go ahead and plug it into the first one. So it's going to be 3 here and 2 here. Plug that into your calculator. You wind up getting 6 minus 2, which is true. So 6 minus 2 equals 4, that's true. Then we're going to go ahead and plug it into the other one. Now the first parentheses there is the y. So we're going to put 2 there, and then we put 3 there. -3 plus 5 is going to get you 2, so this is also true. Okay? So since both of them are true, you are 100% sure that this point is the solution. If you got a false, that means you messed up and you can go back and fix your answer. Let's go ahead and go to the next problem. Alright, now for this system we have y equals -2 and x minus y equals 2. Alright, the first line is y equals -2. What method would be the best method to use for this one? Alright, so we're going to go ahead and make our xy chart. And in this xy chart, what do we know? Alright, so we have y's are always going to be -2. The x's are going to be 1, 2, 3. Let's plot these 3 points and then connect the dots with a ruler. You can see that it is a horizontal line, and we should already know that every equation that starts with y equals is always going to be a horizontal line. Now for the next equation we have x minus y equals 2. What method would be the best method for this one? Alright, let's go ahead and find the x and y intercepts. Now I want you to go ahead and tell me what the x-intercept is. Okay, so we know that for the x-intercept that the y has to be 0. And since the y is 0, I'm going to cover it up with my thumb. In this case, I don't have a thumb, so I'm just going to use some scribbles. So that right there says x equals 2. You don't have to solve. You just bring down the 2, which is right there. Now go ahead and find the y-intercept. Okay, now for the y-intercept, we know that the x is 0. So since x is 0, I'm just going to cover it up. You can see that it says -y equals 2. So get rid of that negative by dividing by it, and then you wind up getting a -2. Plot the 2 points, and then you wind up getting this line. Alright, so what is the solution to this system? Alright, so our solution is right there, and that point is the point 0, -2. Now you need to check your answer, and when you check your answer, you're going to plug it in. For the first one, you just plug it in the -2 because that's all you have. For the second one, you plug in the 0 for the x, and then the y is -2. Negative times negative is positive, so 0 plus 2 equals 2, which is true. Go ahead and press pause if you need to, otherwise I'm going to the next slide. Now here's the system for number 5. The first line is x plus y equals -6. What is the line going to look like when you graph it? Alright, so for this one I used the thumb method. You put -6, 0 for the x, 0, -6 for the y. These 2 points are located here and here. Connect the dots with a ruler. That's what it looks like. So what does the line y equals 2x minus 3 look like? Alright, now for this one I use slope-intercept form. We know that m is 2, y is 0, -3. So you plot 0, -3. The slope tells you to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And if you want to go backwards, you go down 2 to the left 1. Connect the dots and you get this line. All right, so what's the solution? So the solution is -1, -5. Okay, let me go ahead and check the answer really quick. Let's go to the next one. All right, now for number 6, the first line we have is 2x minus y equals 4. Go ahead and find the x and y intercept using the thumb method. All right, now for this one, the x and y intercepts would be 2, 0, and 0, -4. When you plot the points, this is what the graph looks like. All right, the second one is also in standard form, so go ahead and find the x and y intercept for this one. All right, the x and y intercept for this one is 1, 0, and 0, -2. So this is what the graph looks like. Now remember, where the two lines intersect is the solution. So where do these two lines intersect? All right, they do not intersect. And when they do not intersect, that means there is no solution because they don't meet at all. So you can either write no solution or you can draw the symbol. Now for number 7, we have it in standard form again. What is the x and y intercept for this equation? All right, for this one we have 2, 0, and 0, -3. Plot those points, and then this is what it looks like. Now the next one is in slope-intercept form. So what is the slope and the y-intercept? All right, the slope is 3 over 2, which tells you to go up 3 to the right 2. And then the y-intercept is 0, -3. So now let's go ahead and plot this point 0, -3, which is located right here. Now it tells me to go up 3 to the right 2. So if I go up 3 to the right 2, you can see that I'm still on the line. I'm going to do it again. Up 3 to the right 2, I'm still on the line. Up 3 to the right 2, I'm still on the line. So if you connect these dots, you can see that it looks like this graph. All right? So in this case, where do you see that they have common points? Where do they intersect? All right, they actually intersect everywhere because every single point on here is a solution. This point's a solution, this point, this point, this point, this point. So since every single point on both lines is a solution, we can say that there is an infinite amount of solutions. So you say infinitely many solutions. No, you can either keep it as infinitely many solutions or you can abbreviate it to be IMS. All right? Now let's go to the last page. Now these are the 3 representations of the amount of solutions that a system can have. So what I need you to do is look at the graph and tell me how many solutions does each of the graphs have. All right, now for number 8, you can see that there's only one solution. That one solution is this intersection point right over here. All right, number 9 has no solution because they don't intersect. And if you look closely, you can see 2 sets of arrows in number 10, right here and here, here and here, meaning there's 2 lines that are overlapping. And when you have 2 lines that are overlapping, we know that that is IMS. Okay? All right, guys, that's it. I'll see you tomorrow. Have a good one.